So, my dear friends, Oza, again, we are talking on series of topics of power system protection. Right now, we are on the topic of generator protection. We have just initiated generator protection in short tutorial on generator protection 1. Now we will go ahead in generator protection. What are the different kinds of protection that we will see one by one? Probably it will take about 10 tutorial classes of some 45 minutes each, because generator protection is a lengthy subject. Just going ahead. Very important thing is in generator, there are three kinds of protections: class A, class B, and class C. You see, this is very important for generator because once say mostly 59% of generation in world, or maybe in India, I don't know exactly, but some 59% is coal-fired. I mean, the generation by coal-fired boilers, using coal-fired boilers and steam turbines. So if it trips, it takes 7 hours to start if the boiler is in completely cold condition. Otherwise also it cannot start within 10 minutes or 5 minutes. So you have to divide this protections in different classes. Class A protection is for very severe faults, very serious, I mean faults which are very serious in nature. Usually internal faults within generator transformer, unit auxiliary transformer, any prime mover, that is steam turbine or boiler. So if any such faults is there, serious fault is there, then you have to trip class A, because as I told you, 2 into 660 megawatts generator, which turbine, boiler, etc., all ancillaries, it costs about 1675 crores. So you cannot think of this big damage to the generator. So class A, right? Mostly class A protections are instantaneous, mostly, because you see the damage is very high. So you will find that class A protections are instantaneous. Most of the class A protections are instantaneous. What are the actions that are initiated when class A protection trips? Generator breaker is tripped. Actually, I have written hardly 7 or 8. Actually, I told you last time that about 48 events occur. 48 things are occurring. I am not enlisting all 48 because it would be too lengthy. And those who are really dealing with generator may need to understand that much. And we are not talking for that class, for that very small class. We are talking for in general. But yet I am giving you quite many details. Generator breaker is stripped. 52G. That is, generator is disconnected from infinite bus. So fault being fed from infinite bus stops. That one thing is done. Then generator field breaker is stripped, because you have not to produce electricity. Otherwise generator will feed its own fault. But yet, as I told you, the generator is running because turbine is running. Steam is being fed. So the fault is being fed. So generator has to be stopped. You cannot run the generator. Therefore, turbine has to be tripped. That means the steam stop valve has to be closed immediately. On turbine, there are two kinds of valves: two steam stop valves and two steam control valves on both sides of turbine. Steam stop valve means it will immediately, it has got only two states, 0 or 1. 0 means completely closed, 1 means completely open. Whereas steam control valve can be opened or closed to 0%, 10%, 20%, 30%, because it is to control the load on the generator. That is different thing. But here, when you want to trip the turbine, you have to stop the steam stop valve. Then when you do not want steam, why should you run the boiler? So boiler has to be tripped. And once you trip the boiler, boiler starts cooling down. That is a big thing. Therefore, once class A trips, all people around will be very seriously working and they would like to bring back the generator to infinite bus as fast as possible. But as I told you, one of my friends told that they could do it in a very record-breaking time. They were praised by the Gujarat Electricity Board at that time. They could bring back the generator after class A trip within 1.5 hours. I mean, record-breaking time. That is the fastest time that you can bring back the generator. Generator field breaker is tripped. Incomer breakers of unit auxiliary transformers are tripped because now you are not feeding power to 6.6 kV bus through generator. You are feeding through station transformer. And therefore, tie breakers between auxiliary station bus and auxiliary unit bus are closed. They are normally open. As a sequence of class A protection, the tie breakers are closed. All unit auxiliaries are tripped. All unit auxiliaries, BFP, PFN, ID fan, FD fan, condensate extraction pump, all unit auxiliaries. Those feed the unit are closed. And class A trip enunciation appears. This is what happens when class A trip occurs, right? But if the fault is not that very serious, you see, not very serious. That means usually fault outside the generator, not within the generator. Then you see, when you trip the class A protection, what do? You trip immediately. When you trip immediately, then there is a danger of overspeeding. Not the danger, overspeeding does occur. And therefore, special braking schemes are there. When class A trip occurs, special braking schemes, very specialized and costly braking schemes will break the generator, because you see, if 3000 rpm is normal speed, if speed goes beyond that, the rotor conductors will be thrown out of the rotor. It will break the rotor wedges and will come out of the rotor. So you cannot allow that. So special braking system is there. And another thing, that you are not using the kinetic energy of generator. It is running. So it is better you use the kinetic energy of the generator. So in class B protection, what do they do? In class B protection, we do not trip the generator breaker. What do? We trip the boiler. Flames are quenched. Turbine stop valve is closed. So turbine is tripped. Class B trip enunciation will appear. And therefore, generator will keep running. You see, you trip the turbine, but generator has its own inertia, several 100 tons or 200 tons of mass. It is running. It is running and it is feeding the bus. But obviously, because mechanical power is lost, therefore, the speed of the generator will go on reducing. Thereby, you are using the kinetic energy of generator. So it will go on feeding the bus until the forward power reaches up to 0.5%. That 0.5% or 3%, that depends upon the type of turbine, but some percentage. Say in steam turbo alternators, coal-fired boilers, it is 0.5%. When forward power is below 0.5%, then class A protection will be initiated. So class B, after all, is going to become class A, but it will use the kinetic energy of the generator, and this low forward power is sensed by low forward power relay. So all class B protections are routed through low forward power relays. Therefore, low forward power relay is a very important relay in the generator. You see, in 210 megawatt, there are two low forward power relays. That means relay backup, duplication of relays, and one reverse power relay. Three relays are used. Very important protection, low forward power relays. So this is what I told, right? But consequences of certain faults are not at all serious. Say there is a fault on a line emanating from a generator. Generator, then generator transformer, then generator breaker, then bus, and then lines are going. On one of the lines, there is a fault, any kind of fault. That is to be cleared by distance protection of the line. If distance protection fails, then there is backup overcurrent and earth fault for line. If that also fails, then generator transformer secondary, there is a protection. That is generator transformer secondary overcurrent and earth fault protection will operate. That protection is class C protection. And in class C protection, you simply operate the generator breaker. Just simply open the generator breaker. Generator will keep running on house load. That is 10% of the load. Required braking will be done, but generator will be running at 10% load. So when you find out the reason that breaker did not trip, some line breaker did not trip, you trip it manually and then synchronize the generator with bus. That is hardly 5 minutes, 10 minutes job. Therefore, class C protection is very important. Therefore, hence the class C protection is very important. So with this, we start one kind of protection, right? After discussing class A, class B, class C, we start one kind of protection. Differential protection. Very important protection for generator. For any fault within the generator winding, this protection is only unit protection. Any fault within generator winding. And we have to yet understand that generator winding means it is in the slots, and over there is an insulation, and then there is stator core. So failure means the stator conductor will not touch the core. There will be an arc. So that generator to core is an earth fault. And if you calculate the fault current as per the rule 3 EPH upon Z1 plus Z2 plus Z0. Z1, that is the subtransient reactance, because you see, you should think of the worst case, that is 20%. And for 210 megawatt, it is roughly 0.2 ohms. The negative sequence reactance is also of the order of 20%. Zero sequence is hardly 10%. So 0.5. 3 EPH will be 3 into 15750 because 15.75 kV upon 0.5. You see, enormous current, thousands of ampere of current will pass, and that current will center the laminations, and therefore you have to remove that much part, and repairing of generator, and more than repairing, if the generator remains closed for 1 day, 2 days, 3 days, or a week, the revenue that is lost. Yes, just think of revenue. 210 megawatt means roughly 2 lakh kilowatt. And for 1 hour, it is 2 lakh kilowatt hour. If you take 6 rupees, then within 1 hour, you are losing 12 lakhs of rupees. If you stop the generator for 3 days, then you just think of, you see. Therefore, generator neutral is always grounded through very heavy impedance, roughly 4,000 ohms. And you will get exclaimed that if the earth fault occurs at the generator terminal, then the fault current in primary of the generator is 2 ampere. 2. અમે ગુજરાતીમાં એને બગડે 2 કહીએ. 2. Just 2 ampere current is passing. And 2 ampere, you see, rated current 210 megawatt, 15.75 kV is 9050. CT1 and CT2 are 10,000 by 5 ampere CDs. So it is reproducing 2000 times less. So 2 ampere is 1 milliampere. 1 milliampere current can never be detected by any current operated relay. So when we talk about earth fault, we will talk at depth, but try to understand that this differential protection is not going to protect for earth faults in the generator winding. One very clear fact. The differential protection cannot protect the generator from earth faults. It can protect from double line and triple line fault only. Only double line and triple line fault, nothing else. Then the things are very clear. If there is a fault outside the generator, this we have seen otherwise also in earlier classes when we were talking about the differential protection fundamentals, that when the fault occurs outside or there is no fault, the generator is running normally, then primary currents are equal. Therefore, secondary currents are also equal. I1, small I1 is equal to small I2. Capital I1 equal to capital I2. Small I1 equal to small I2. So I1 minus I2 that is flowing through relay is 0. Relay does not operate. If there is an internal fault, then I2 reverses, my dear friends, because the current from the whole system will be fed. I2 will be very large as such. Current flowing through relay will be I1 plus I2. Relay will operate, and that is class A protection. Immediately everything will come to halt. That is generator differential protection. So what are the requirements of generator differential protection? That current transformers CT1 and CT2 needs to be connected with correct polarity as shown. You see, dot is showing the polarity. ML, you cannot make a mistake. While commissioning a generator, you have to take care. The differential protection shall operate sensitively for internal faults. If internal fault occurs, it should be very sensitive. Usual sensitivity is 10%. 5 ampere, 10,000 by 5 is the CD. We are setting at 0.5 ampere. If the current is more than 0.5 ampere, the relay will operate. High sensitivity. But it should remain stable against external force. Very difficult condition. Very. Writing is very easy. It shall remain stable against external force. You can read and you can write also in the paper. Very simple. But in practice, this is not possible. This is not possible because two CTs can never be identical. Two things you manufacture can never be identical. Their saturation characteristics will not match. Right? They may match for rated currents, but when external fault occurs, 10 times, 20 times the current is passing. 5 times, 20% is the subtransient reactance. 5 times the current, 5 times normal current is 10,000 ampere. 5 times is 50 kiloampere of current is passing. So at that time, CTs will saturate and not equally saturate. There will be a mismatch. And therefore, the current I1 minus I2 will pass. And because we have sensitively set, it may operate. So that it may not operate for external fault, you have to do something. You have to do something. One thing. Second thing, relay coil should be connected at the equipotential points. That is, A and B should be equipotential. VAB should be 0. Now, geography of the power plant will not allow you to keep relay exactly between CT1 and CT2. See, it may be near CT1 or it may be near CT2. And then one CT will be burdened more, another CT, because IL, the lead burden will be more for one CT. And therefore, you see, the mismatch will occur, and therefore there can be mal-operation once again. So you have to do something to stop the mal-operation for external force. What do we, and obviously differential relay should be immune to harmonics. Means if the lightning stroke or something, some noise comes off which is having different frequency than 50 hertz, it should be sensitive to only fundamental. That is the main thing. So if everything is ideal, it is like this. EMF of CT1 and EMF of CT2 is same. They are very identical. RCT is the CT secondary resistance, same for both CT. RL, we have connected exactly at the middle, which is not possible. This is just ideal. This is not possible. Therefore, V1 equal to V2. That is voltage if you measure across CT1 and CT2, they are equal. And if you see, you have placed the relay at the middle where voltage is 0. So relay does not operate. Very ideal. This is not possible. This is not possible. If external fault occurs, then E2 will reverse and it will be high because the whole system is feeding. Therefore, the voltage across CT will be very high. Probably the voltage across relay will be very high and relay insulation may be damaged. Therefore, also, and for keeping the relay stable against external fault, we connect stabilizing resistance. IR step is the voltage drop across stabilizer, and IZR, Z is the impedance of relay. That is the voltage across the relay. So this voltage is quite high and relay will certainly operate and class A protection will operate. That is differential protection. If I go further, this is the diagram. That is the equivalent circuit. CT1 and CT2. So always in CD, if you take the equivalent circuit, there is a shunt branch, LM1 and LM2. That is the shunt inductance is the resistance we usually ignore. Then RCT. RCT is within the CD, but we are showing an equivalent circuit outside. RL that we have laid because CT is near generator and relay is in control room. So RL, lead resistance. On another side also RCT and RL, LM1 and LM2. RR is the relay resistance, LR is the relay inductance, but usually high resistance differential scheme, LR is very much small with reference to RR and we ignore LR. And to keep the relay stable against external fault so that the current passing through the relay does not cross the setting, we connect the stabilizing resistance R step. Now, our duty in the whole thing is to find out the correct value of R step so that the relay is stable against external fault yet not very insensitive. Because connecting R step to an extent you are making the relay insensitive against internal faults. So you have to manage the balance. You have to manage the balance. So we consider the worst possibility. Worst possibility means CT1 is under flat saturation. CT1 is under flat saturation. CT1 is ideal. CT1 is ideal. Ideal means there's no shunt branch. It is very 1000 is 10,000 is exactly reproduced just fine. Not possible. This is just an assumption to calculate R step. So LM1 is infinite. So LM1 is infinite means it is open circuit. And LM2 is short circuit because it has gone to flat saturation, worst condition. CT2 has gone to flat saturation. So if you consider that the equivalent circuit is like this, RCT RL through which IF fault current is passing, that fault current will be roughly 5 times because 20% is the subtransient, direct axis subtransient reactance, XD double dash. Then relay is connected here. That across relay, VR is the voltage. RR, LR and R step. I told you LR we will ignore. So if you go further and if you write the equation, VR is equal to IF into RCT plus RL. And VR is equal to IR into RR plus RR. And LR we will ignore. So if you go further, our equation is R step is equal to IF. IS is IR, but I am considering the for set current IS. So value of R step from that is IF RCT plus RL upon IS minus RR. This value of R step you should connect. But what we do not connect this because we have considered the worst condition. So usual practice in the field is 1/3 of so connected R step is connected. If your value is 180 ohms, then you connect 60 ohms. Right? 1/3 of this value is connected. And if you have to purchase the series perfectly, knee point voltage should be 2 times IF RCT plus RL. Here 2 times is forgotten. It has to be V KPV should be 2 times IF RCT plus RL. It's 2 by typo. I mean, it is a typo. A typographical mistake has been done because I am writing and I'm giving to somebody else. So for decoration, so mistakes are very rarely but happening. But that KPV should be 2 IF RCT plus RL. And yet, if you want better cities, introduce air gap in the CT core. Cross section of the CT core should be as high as possible, or use linear couplers. So if you use like this, then your differential protection is perfect. As such, double line and triple line fault in generator winding are quite rare. Probably never happens. I was in Gujarat Electricity Board for 3 years, and all forced outages were reported to me. I was deputy engineer, but because I was looking after protection, all forced outages were reported to me. I have not seen a single outage because of the operation of differential protection, because it's a very thick conductor and hollow conductor. Within the hollow, the distilled water is flowing and very nicely designed. So possibility of double line or triple line fault, if at all it may occur in overhung portion. Otherwise, if differential protection operates, people will doubt something else. And that I have discussed in one of the seminars, one of the webinars when we took. AC circuit is like this, the detailed AC circuit. Generator windings are double star windings because 9,000 ampere is flowing. To dissipate that heat is very difficult, therefore it is divided into 2 parts. We have to dissipate only 4,500 ampere. So double star winding is used. 87 GR, GY, GB are differential relays. Surge diverter SD will divert the high frequency surges. So 87 GR, GY and GB are rather sensitive to only fundamental and nothing else. Then you are seeing the stabilizing resistance and then the lines. So, and the neutral is connected through NGT, and across the NGT secondary there is a reactor R, and about that we'll talk further, not now, but this is the detailed circuit of the generator differential protection. The DC circuit is operation of 87 GR, GY, GB. Any of the 3 relays operates. That means double line or triple line fault occurs. Then 86 G1. It is not written. There are 3 relays, 86 G1, Class A protection 86G2, Class B protection and 86G3, Class C protection. So 86G1 will operate and Class A trip will be initiated. 48 events will occur. Complete unit will come to halt. It is Class A trip and instantaneously within a cycle or two, very fast, right? Because it's a very dangerous fault. Generator differential internal fault within the generator is very. So 86G, if you see, it's a high-speed tripping relay. It is also known as lockout relay. Once it operates, it remains operated. It does not, it has to be manually reset. Therefore, it is also known as the lockout relay 86G. With this, my friends, I come to an end of this tutorial. I like to read a sentence every time. Greed is the fear of inner emptiness. If you are greedy because from within you are feeling empty. If you are fulfilled from within, if you have satisfaction from within, whatever God has given is enough. Not only enough, you do not deserve that much too. Whatever God has given to you is more than enough. He is giving more than enough. He is the giver. He likes to give. He never keeps you empty. He keeps on giving. You do not deserve. You means I also do not deserve, my friends. When I say you, I am included. I also do not deserve what God is giving to me every moment. Every moment, huh? Every moment is giving. But we do not feel it enough. And therefore we want more. We want more. We want more. 10 lakhs rupees are received. I want 10 crore. 10 crores are received. I want 100 crore. Huh? Ambani is 100 crore rupees. Then Adani crosses him. There is no end to it. There is no end to the grid. Grid is rather it is infinite. Grid is like infinite. It never ends. So be happy with whatever you have, because whatever you have is not what you deserve. Whatever I have is not what I deserve. God has given me more than what I deserve. With that, I will remember adapt me. We have reached some 700 view hours. My aim is 4,000 view hours. So you will say that I was telling that I should not be greedy. But once again, I'm showing my greed. But this greed is not for having something. This greed is for sharing the knowledge. This greed is for sharing my knowledge, whatever I have, whatever. I don't know that I'm knowing everything in protection, but whatever I have, I am trying to share. So please, friends, you hear the video, you will like it, and you share with as many friends as you can. And let us be rich. Let Adapt Me be rich on YouTube. Right? And let Adapt Me, name of Adapt Me. Because Adapt Me has no big advertisements. Adapt Me does not have big show. Adapt Me is yet a child. So to make Adapt Me a young man, you have to work. You are the ambassadors. The persons who are hearing my video are my ambassadors. So please work as good ambassadors. Please share to 100 persons. 150 persons, 200 persons, as many friends as you know, as many groups as you know. And there are many WhatsApp groups. So please do that. With that request, thank you and good day.